Hello and welcome. Okay, so today's tutorial is one I've been working on for a while, like the underlying code part of it and overall design, learning a lot about the functionality. So I'm excited to bring it all to you. So it's going to be a walkthrough of building a RAG-based chatbot. I'm not the first person to do this, certainly not going to be the last, but it's something that's been at the back of my mind as a larger project over the winter break to try and test out to see how all these pieces can fit together and just essentially learn a lot more about all of them. So that's what I plan to bring you all through today. A bit of the background as to why I did it, a demo of what we've actually built here, and talk about the structure of it all as it exists as like the final application, then start to dig into more of the unique components that get linked together to make it what it is. And then last but not least, other like thoughts and tools I have on like ways to improve it. Some of them I have like dipped my toe in the water with. Other ones, if you want to go wild and take this when it's on like GitHub and go wild with it, be my guest. I'd be delighted to see that. So just to give you a bit of background of who I am, what I'm trying to do. Well, I'm Owen. I'm the founder of Build AI First. It started off as just like a bit of a nugget of an idea. When I initially started working like at a company, at a startup, there's a lot of different like growth leaders out there, like Yerm, like Segment. There was really good content published by the likes of Clearbit and Uber and Airbnb blogs. As time has gone on, those like core areas where you go for like top-notch resources have kind of faded away. The content lives across like LinkedIn and YouTube, or sometimes it doesn't exist at all. It's just like nested in like tools that you have to pay for and get licenses for. So what I'm trying to do is make it a little bit more like open source. Starting off as me, we did a launch a couple of weeks ago and we got some like really interesting people into the community. So I'm hoping to engage with them more in the coming weeks. But yeah, our goal is make transparent technical tutorials and give you fuel for your ideas and just throw stuff out there, basically see what sticks and maybe help you in your role or in your side projects. Just take some of the AI tools that are out there, understand them better so that you can put them to better use. So that's the last of the pitches. Why build a chatbot? Well, it's kind of three reasons I could like formulate in my head. One, I really like the All In podcast. A lot of the more recent episodes were around, or I guess pre-Christmas, a lot of them were around interviewing the alternative presidential candidates for 2024. I'm actually not able to vote in those, unfortunately, but I did want to learn more about them, learn more about their like backgrounds, what they stand for, their views on certain policies that I would care about. Um, I had experimented with lots of tools, but really hadn't built anything comprehensive. I'd done lots of scripts in my spare time and at work to like scrape X from Y and push it into some other place, or I need to run inference on a large document, or I need to do X, Y, or Z. I'd done lots of little small pieces, but nothing that like tied stuff together where I'd need to iterate to make stuff like and improve the outcome, or just really like fine tune things to compare one iteration to the next. And then, yeah, I guess like third point, a chatbot is a collection of building blocks. Just like I mentioned there, there's nuance behind each component. Like quality in means quality out, and a chatbot has like this like long chain of events that needs to happen. So if you don't have something really good and really precise up the front, what you're going to get out the far side is going to be even worse. And then there's a feedback loop, so you're kind of just like looping back worse and worse quality the whole time. So it gave a lot of scope to be creative and play around with lots of different tools. So overall objective was I liked the All In podcast. I wanted to learn more about the four interviews that took place. with like the alternative presidential candidates, and then basically, yeah, learn more about RAG, which we'll get into, prompt engineering, and lots more in the process. Not that this is the be all and end all, but learn more about it all so that I could apply it in different contexts going forward. So that's enough of a walkthrough here. Let's look at a demo. So the whole thing was built in Streamlit, and it gives you the chance here to pick one of the candidates. It's trained on the back end based on their all-in podcast. So we're gonna pick Vivek. He's a pretty hot topic at the moment. We can say, what political party does he represent? So you can ask a pretty basic question. Some of them, I'd play with temperature, but it's going to give you factual information. It's not going to go off and hallucinate, which we'll talk about as well. We can get into something a bit deeper then, like what are his political views on Donald Trump? And let's go with that. Oh, he definitely has views. Yeah. So mostly good. He also believes Trump's behavior had a negative impact on a portion of the population, causing them to lose their ability to think independently. One other thing I've been thinking about are what are his views on immigration. Yeah, believes in a merit-based immigration system, supports point-based system, prioritizes skills and civic commitments. National identity is important to move forward. That's interesting. What are we can say, what does he think of woke culture? Must be offered. I think he wrote some book on woke culture. Has he written a book on woke culture? I think, yeah. Huh. Okay, and then if president, how would he manage like fiscal spending? And focus on administrative actions that do not require. Does he have a budgeting strategy for this? So I'm kind of asking different questions that we'll come back to later on, but you can see here at no point have I mentioned Vivek. Some of them are just like straight up questions, so we're just querying one, like embeddings at the back of this chat. But what's kind of nice is when I talk about like the fiscal spending here, I can then follow up with a question of like, does he have a budgeting strategy for this? This being the word that's key in that sentence that needs to, the chatbot needs to understand what does the word this refer to. So I talked about like budgeting and fiscal spending. Does he have a budgeting strategy for this? So yeah, candidate's budgeting strategy is to focus on grassroots fundraising and donations rather than large-scale donations. Interesting. So this is one place that certainly needs improvement. They plan to use their strong grassroots, unconventional rules. So here, there's lots of room for improvement, but it mixes some of his like personal fundraising objectives for the campaign with actual like fiscal issues. So maybe say, tell me only about his plans for government budgeting. Well, I guess there's other stuff I can work on here, but it's basically giving me back the same answer. In any case, let's look at the back end and see maybe where we can do some improvement. So we went through the demo. I'm going to show the code after this section. But what is RAG? So like LLMs are trained on like so many data points, but they're not trained on your data. So you go to ChatGPT, you can ask it, you can probably ask it what's the meaning of life, but it'll give you an answer. You can ask it what day of the week was the 1st of January 2024. It'll know that, but it's not going to know what day of the week was I born, or some of the questions there we asked about Vivek that only happened on the podcast. It's not going to know that data. So hallucination can be a massive side effect when you ask it a question. So we'll say the new president got elected today, and we ask ChatGPT, who's the president of the US. It's going to have been trained on data from like months ago. So we're going to pass that in, and it's just going to try and make up, or it's going to refer to Joe Biden. It's just not going to have up-to-date information. So when you have particular use cases and you need updated answers, or you want to train it on your own data, RAG has been a useful architecture for that. So I like this diagram I pulled from online, but when we use RAG, we're going to mix like question with the LLM. So that's basically how GPT works today, and add in something called a retriever. Retriever can be, think of it as like a database of your own data, or it could be an external source that we query for live information. So Wikipedia, New York Times, YouTube. What we basically do then is the question goes straight to the LLM. So the LLM is like, great, I'm storing onto this, but I'm also waiting to get a little bit more context about it. And then that comes from feeding the retriever the same question, getting all the relevant information from the source, curating it in some way, and then giving it back to the LLM. So what we have here at the generator is it knows the question, and it knows basically this snippet, or it could be in lots of different formats, but it's told Joe Biden is X and got into office on Y. So then when the LLM needs to generate its answer to the question, it knows then, based on the context, Joe Biden is the answer I need to return here. So how do we implement RAG? Basically, we went through a lot of it there, but it's about retrieving relevant documents from whatever corpus of data you have, integrating it then with some sort of model like GPT, which is your LLM, and continue training it to make it better. So question comes in, we query that against the storage, that comes into our prompt. The question itself goes directly in there, and so does memory in most cases. I say most cases because I have something to show in a few minutes, but yeah, that's how most people do it. How did we use RAG? Well, you can see the interface I was playing with. This is where the initial question is posed. And then on top of that, that goes into the prompt directly. I use FACE or FAS, I'm not sure how to pronounce it, but it's like Facebook's vector database. The question goes in there, we get out chunks, and that goes into the prompt. And then you could see here, let's change to a different candidate and pose a question, but memory is super important as well. So we'll say, watch political or watch roles in government has Dean held. What is a follow-on question we can ask? He's currently a member. We'll say, what other political bodies or what other political bodies has he been involved with. So here, like, at no point have I had to mention Dean, which is kind of a bias I've inserted up the top here based on the candidate you select. But it knows that we've spoken somewhat about like politics and government and something about like a role in government. So then when we ask about like what other stuff has he been involved with, we need to feed back that memory, like the previous answer, previous question, so that it knows not to give the same answer again, but to basically curate it and go a level deeper. So that's why feeding back the memory is important. When you have that like back and forth sort of conversation, you don't want the bot to always give you the exact same answer. And yeah, for LLM, I've been mentioning like GPT a lot. Initially I started off testing with DaVinci 003, but that recently got deprecated for something more powerful, and that's 3.5 Turbo. So maybe let's jump into what I've promised, which is the app and the code. So there's a lot that we'll go through here today. I'm going to minimize some of those ones, but it's actually pretty simple. Like the work goes into developing all of the nuance behind the scenes, but like starting up the top, I'll show you the interface again, but we need to generate some like sort of side panels, some introduction, some chat interface. So what I used was like Streamlit. So we're going to get basically the candidate the person is going to select. We're going to show some like text on screen, like the header, some side panel information. That's all here. We're going to point a link to this blog when I go live. And then we want to maintain state between all the messages. So each of our, each time we ask a question, it's going to go back 3 messages and have that context. We don't want to keep passing in every single thing. We just want the most recent ones being passed in. So if I asked ages ago, what age is he? After 3 messages, that will get phased out from the context passed into the most recent prompt. So when I talk about answer being fed back here, what I found with a little bit of testing is if that was like greater than 5, it gave poor quality answers. If it was 0 or 1, it also gave poor quality answers. So 3 to 5-ish was a little kind of iteration I came to. That's why k equals 3. We just want to display the chat messages. We have like our role as the asker, and we have the role of the bot, which is going to give us back. Sorry, we're asking the question, the bot's going to give us back the answer, and then we need something where we accept input and do something with it. So, the user hasn't selected a candidate from the left side panel, we basically give them a warning to do so. Obviously, if they have, we start to do some logic. So what do we do here? We say, okay, great, the user's entered a question. Let's show that on the display as their question, like let's log it. Then we want to display assistant response to the user. So this is where we come into taking the question received and feeding it back with an answer. So we start off with an empty message, that's the bot's response. Then we pass in our prompt, our memory, the selected candidate, because we need to know, well, if it's Vivek or Dean Phillips, what sort of database or vector store to query. And then right now I pass in another variable here, which we'll look at in more detail, is the return like source. So if you wanted to debug and know, oh, it gave that weird answer for Vivek a couple of minutes ago, because it looked at his like personal mixed with his government stuff, how would we make that answer better? So being able to return true here, we'll give it all in the terminal, print it out wherever you want, and you can start to figure out where your model needs like fine tuning. So we're just going to return the answer here. And then we're going to save the answer to our memory, which is this part. And what else are we gonna look at? Load the memory variables, full response, and then this is just printing so that I can see in the background here what's happening. So like the last question we asked was around what roles in government has he held? And then we can start to see the results. Oh yeah, so sorry, the last question I asked was around, this is the last question we asked, which is what other political parties. We can start to see we're storing all the same context here of he was representing the 3rd district. We know like what the first question was, and then we store here the full answer that was returned. So all we're doing here is like printing out the context that's passed in under each question so that we can start to see the full picture. And then this is kind of a hack. I'm sure there's a better way to do it, but so that when you ask a question, it kind of gives you the bot's answer piece by piece. And we basically like stream the response back. So if I go to here and say, what's a good question? Where can I find more information on him? Is there a website? It like starts to buffer this answer back rather than just paste in the full text. So that's what that piece does. And then, yeah, that's basically it. So it's like rinse and repeat. The main things then up the top that are not in the main function are the following. So if a new candidate is chosen, we want to reset the memory in messages. A different optimization we can make is be able to converse with all the candidates at the same time. I think that both gets confusing from a user perspective and like a UX perspective, but definitely on the back end, it would get very nuanced to figure out if a question comes in now, does it refer to the candidate they looked at 2 messages ago or 4 messages ago? I think it's quite a complex thing that I need to think about for a little bit longer. But here all we're doing is if the candidate is changed on the left-hand side, let's reset the memory, which means wipe the stored memory, give it a new buffer, and then I just print it out to help myself with debugging. Similarly, every time we ask a question, or I guess the first time we ask a question in this window, in this case it's about Dean Phillips, we want to be able to pass in the proper reference to the vector store database to the underlying model, like our RAG structure. So all we do here is we do some logic around this is trying to figure out what are all the options I can show here, like from Dean to Chris Christie. So we just iterate through our embeddings like folder there. We present all the options, and then later on that helps us pass in a particular format what one of those vector databases we want to query. So there's a lot going on here, and there's also not a lot. When I push this to my repo, you'll be able to see a lot of like the inspiration I took. So like for Streamlit, that was quite simple. Once you found their tutorial guides, they had some that were like related to chatbots. So some of that was just like assembly. But yeah, overall it's a main function that does some like UI work. Once we like take in a message, we just need to like pass it to the model at the back end, present the answers, do some debugging and like printing to our console so that we can figure out what's going on when stuff goes wrong. And then there is certainly some nuance in like the headers of these functions. Like basically we just want to reset the memory if someone changes the input. So if we look for where this gets called, if the select box of where you can select the candidates is changed, that's what we call reset memory. And then this get candidates, not that, that is called initially when we run the main function, but additionally when we want to present those candidates. So yeah, it took a while to get here, but you'll be able to recreate that just with a little bit of knowledge and a little bit more time spent on like reading through it. So going back to our components, we've seen a lot of the nuts and bolts just there, but overall taking one step back, behind the UI and behind that like app.py file, generating the vector store is probably the most important part. And there's a lot of components that go into that. So number one was we're querying data from the All In podcast. Well, how do we query it? Or where does that where does the underlying like data come from? So structurally wise, the podcasts exist on YouTube, and they exist in like video format. We need to get that video / audio, be able to transcribe it, so go from like speech to text. Text alone isn't good enough for us to like query on for this, so we need to do some like data cleaning in your favorite like data analysis tool. For this, I think I use like a mixture of like Google Sheets and Excel, just because I'm better with the formulas in one over the other. Then we need to basically start to put that into a structure where it is able to be used by our vector store. Vector store is something I keep mentioning, and I will explain it better, but we need to get all of our documents in a proper format. Then we need to make them into smaller bite-sized elements that are called chunks, and then those chunks can be stored in a vector store like Face. Oh, I guess that reminds me of Facebook, so maybe that's where that comes from. But I'll kind of leave some of the nuance here for later slides, but starting to look at the early ones, there was speech to text audio transcription. So we can dive into that here, but on the embeddings on the podcast to here, so we want to do get interviews. So step one is figure out where these interviews exist and get like the MP3 versions of them. So super simple little script. We have a dictionary here. We iterate over all of the podcasts. We use the PyTube library, and basically we download each of them and store them locally. So we stored each of like these podcasts as the name of the candidate.mp3. That covers that first part for us. Now we need to get into speech to text. So if I do audio transcription, there was two main models I kind of went back and forward with. There was this one, which was Distill. Not that. Let me find it here. So this one I had initially looked at based on finding something interesting on Twitter, but it just shows like that this new Distill Whisper like model was so much quicker. As I tested it, I found that its quality of output was not as good. So we'll get to that in a second. But over here, this is what I actually went with. So we just used Whisper, which is provided by OpenAI. We then used their small model. There is a trade-off between like quality and runtime. I was doing everything on my laptop, so I opted for smaller model just because it ended up taking a long time to run over like 3 hours of audio. But yeah, we pass in our reference to the MP3s, loop over each of them, and then we output our response in the .text files. So at the end of this, we've gone from YouTube videos to some sort of .txt file. So now we need to perform our cleaning. So with cleaning in mind, we have demo.py, model embeddings. And let me rename this as .py. So you can see here a lot of stuff commented out. It took a bit of iteration to get through individual like chunks and different strategies, but overall we're gonna like need to take in what we have here as a CSV. So this requires some explaining. So we'll jump here. Training data is the most important part of all of this, and it's the least fun part. So we went from like a .txt file into something that needs to be cleaned and understandable and embeddable for the model. So let me just pull up an example. Okay, so if we look at the output of one of the original like .txt files, it's just in CSV format here. It outputted after we did some cleanup, everything in a question column, and then its assumed answer in the next one. What we needed to clean it up to do was put it into a better format. So what I ended up landing on was get the topic, get like some subtopic, speaker, question, and answer. So here, like topic for all of them is candidate questioning. Subtopic could be like introduction or like present day, Ukraine, etc. Speaker, we just use the same ones. This is Vivek's, and then question stores that in one and its corresponding answer in the next. Okay, so that like creating this whole structure is definitely not fun. Initially I started off with, okay, maybe once I have the transcription, maybe it's like manually doable. Maybe there's like an easy way to do it. The answer is no. So going from that like .txt file of like Vivek, which is this one, into something that's a bit more tidied up was not easy. So what I ended up doing to help create that CSV was this script here. Input is a raw text file. The output should be like a CSV with our required columns. And the process was, it was crude, but anywhere like a question mark is used, let's try and split the question and answer on that. So there's nuance to this where it doesn't always work as you expect. So like if Owen's a candidate and he's talking and he's saying, well, someone asked me on the presidential trail, what was my policy on fiscal spending? That ends in a question mark, and then that gets split up. So there is logic that goes on here of like go over the whole like file, break it up into like sentences, try and like figure out if there's a question mark there should be, and then start to pair things in like Q's and A's. So there's a lot of stuff here to just try and do like text formatting, but the output is crude. Like it's 80% there, but the final 20% requires a lot of time to run through. So while this gave me the jump from .txt to CSV, there was still a lot of work needed to go into like actually clean this up, to remove like unnecessary introductions, like some pieces of text that are just like not at all relevant. And I'll show some examples at the end of like room for improvement. I've left some like bugs in here just so we can see them, but certainly not an easy like process or system to run through, and doing it at scale is certainly a craft, but really important to get it right so that you don't bias your model and you have like data that you're trusting in from the get-go. So yeah, there's a lot of cleanup to get to Q&A style. Manually reviewing the data took a long time, and then you have to like iterate on your embeddings. So what I mean by that is if we jump to our actual embeddings process, which is here, we're kind of going into like thinking about the data structure. So should we embed CSVs or PDFs? You think about like the document loaders that actually get it into the database. We also need to think about, okay, well, we can start with the document, but how do we break it up into smaller chunks then to get it in there? There's a lot to consider. So what we initially, or what I landed on was we load the doc, which is as a CSV. As you can see, we had topic and subtopic. They gave us like the important metadata that helps to focus the model in the right direction. We need to break each of those CSVs up into smaller little chunks. Like even rows alone are not going to be good enough. If there's a bunch of text in there, that's like some candidate talking for 5-6 minutes, and that's going to be very hard for the model itself to like piece through. So chunk size, like 1,000 like token size here. Basically think of it as like 1,000 words. So it's a good, like, excuse the pun, it's a good chunk of text. And then the overlap, meaning if we were to look at like a continuous string and try and break it up into pieces, you want each piece to slightly overlap with the last one. So our overlap is like 100 tokens or like 100 words. Then we bring in each of the pieces of metadata from the file. We start to split up the entire file then into our necessary chunks. Then we run embeddings, which is basically we just pass the data to OpenAI's embeddings function. It returns the result, and then we store it in our database. So nothing really complex going on there. And then we just like save it locally, and then we can reference it without needing to rerun embeddings every time. We basically have created a database and stored it locally, so now we can do whatever we want. And then I just posed like 3 different questions to just make sure that it was accurate. So at the end of all of that, we have our vector store. So we have gone speech to text, we've prepared our data painstakingly, and then we've embedded the documents. So what I'd say here is like the takeaway of like you could test forever on like different metadata, different formats, different chunking strategies, different overlapping. Like pick one, see how it does. If it doesn't look quite right on the simple prompt you can give it, try it again. And then just see after like 2 or 3 what works best for you, and then move on from there. There's always better iterations you can do, but I think just never trying to get too blocked on something early on is super important. Okay, V1 chatbot. So now that I have some like actual storage and vector store, I want to get to a point where I can, like in my testing, set up a UI, go back and forth with questions, see how the whole thing works. So I'll load up some stuff in the background here, but what I wanted to get to was I was so like fresh on any which way to like craft this that I ended up landing on 3 different methods of just like learning. Okay, so I wanted to test a few and understand like best performance. So we're going to go into this file here, single model development, and our testing playground. Here is just where I threw any which like model or like method I could read about, and I wanted to like compare them piece by piece. So what we're actually going to do here is kill the UI, and I'll just walk through this really quick. So method 1 was like straight out of the box. I just want to use the function like LangChain can provide, give it all the context, and expect a result. So I have no control over the prompt. Number 2, I think I have it nicely phrased here, but I want something out of the box that I can control the sources and start to move towards a chain, which gives me more control over everything else that goes into it. So here we have like our chain set up. It takes in the retriever, which is our vector store, It's able to format docs, and it takes in a question from the user. It knows our prompt. It knows what like LLM we use, which is just OpenAI's DaVinci or 3.5 Turbo. And then we want to output the data in like some sort of streaming fashion. And then the third one here gives us the most control. It is like fully customized, and we can edit every part of it, and it's still a chain. So here we look at it's kind of two parts to it, but the simplest one is we have our like context passed in. So we have queried our database with the question, we gather all the context, we pass in our question as well, all to our prompt. We then pass the accumulation and aggregation of it all to our LLM, and then pass the result out to the output. So the overall like structure we have here is this is our prompt, and it ends here. So we have like a bit of a system prompt telling what the agent should do, like keep your responses abbreviated. Don't try and make up information you're not like sure on. So then we pass in our context, which is queried from the vector data source, and we pass in our question as well. So important to see in all of this is that there's a lot going on. It does take time to like iterate through it. And so when you have different models, it can become really complex to see, geez, like one by one, they all look pretty simple or straightforward. When I ask it questions, how do I know what's best? So part of that was I set up this sort of structure, which made it all a little bit easier to like test at scale. So I'll run this, but here I just have like a backlog of queries, and we can start to figure out by like printing it out in the console which model starts to look best with time. So you can just run this off the bat, and I have it in like debug mode, so it should stop after each question. And if we pull this guy up, we hit run. Yeah, you can start to see here, I need to run some improvements on the deprecated items I have, but you can see here, like, what's the candidate's name? We get the candidate's name is like Dean Phillips. Candidate's name is Dean Phillips, and if I output number 3, Dean Phillips. So there's some like breakpoints that I still have included, but very quickly you can like iterate through your methods and start to see which one you prefer the best. So like very to the point is method 1, very to the point is method 3. This method 2, I found that it over time, if we were to go through the later questions, started to hallucinate a little bit. And that was just because couldn't control the prompt in the way we wanted. So overall, would highly recommend developing some sort of testing ground like that. I'm going to stop that one. So yeah, definitely it enabled like quick iterations of questions and answers, facilitated easily updating the models themselves. You could just easily hop into the like the playground, play with the prompt, and then get like number 3 to be, well, in the end, it was far better than the other 2. So that's what I went forward with. Then if we start to think about the user interface, so we've gotten from create the embeddings, create the model. Now we want to start like actually putting it to use in sort of the like UI interface. So this is dead in the background, but that's fine. We'll rerun it in a second. Now I want to like ask questions back and forth. So I didn't want to have to deal with like HTML and CSS to create this. I just wanted something that like worked. So Flask seemed like a good choice. Doing some research, Streamlit seemed to be a great match. It gave me components like pre-built. UI kind of just took care of itself, and like even sizing on the screen, it just worked, which was fantastic. And as I tested with it, I started to ask it questions that we've seen earlier here. I quickly found that it was not conversational in nature. I'd say, what party is Chris Christie part of? And then I'd say, what are his views on X? And then you'd get deeper into like nesting of questions and it would give me an answer to that question as if you had just asked a net new person each time. So wasn't the best. So it had no ability to maintain context between the messages because the way I had built it was without this memory piece. So I needed to feed back in the questions and answers. So that's what I started to do here. So the optimization was RAG with history fed in, which is essentially what RAG should be from the get-go. So I did multiple iterations, eventually discovering or kind of landing on two things that had been discussed like online. So one was, think of it as like single prompt. We're going to feed in the context. We're going to feed in the like history and feed in the question all to the one prompt, give that to a singular LLM, and then expect an answer out. The second one, slightly different and like an interesting way of thinking of things, chain two LLMs together. So it's probably easier if I just show this one, but the one on the left here is what we've kind of been talking about the whole time, single model. The next one is this chaining. So initially the first step is get the history and the query. And our aim is to create like an improved question just based off of those two pieces of knowledge alone. Then we're coming up with a more historically relevant and contextual question that I call it the updated question here. We then feed that with our like sources or our context into another prompt, which then outputs or which is then sent to our LLM for the answer. So you'll see the answer there of what I landed on. But if we jump to conversational model development and our playground here, you can see that this is condensed prompt. Oh yeah, this one. I need to clean up some of my comments. But here we're trying to pass in a little bit of everything. Sorry, this is the second one. So with this one, which is singular chain, we're trying to pass in a little bit of everything into our prompt. So this is our template. We're gonna give it like, here's what you should do. Here's like context on the answer. Here's the question. And then we're trying to tell it too much, I think. We're trying to say like, okay, here's context, here's the question, and here's like knowledge that might be useful that occurred in previous like chat messages. And then if we look at number 2, the one that has 2 chains, then what we do instead is when something comes in, we go to like our first method, get the revised question, and then pass that to the second model, which takes the revised question and the revised question and the context to generate the actual output. So revised question comes from condensed prompt, which is up here. And all we're saying is like, you are a glorified rewriter. You're taking in like chat history and an existing question and trying to make the question more specific or more contextual. A lot of stuff here, but it's the same as what we've looked at before. It's the like structure of a chain, get the prompt, pass it to the LLM and get the output. And then when we take that revised question, we essentially pass it back into that previous method 3 we looked at. Nothing really changes. Context we still pass in, and we pass in just the revised question this time, and then return the response. So again, what's super nice is you can run like the testing playground here across the 2, and what I have is the additional like memory chain. So just like we spoke about earlier, this memory feedback is super important. You don't want it to be too long or too short, so that's something you'll need to like play with. I found 3 to be good for my use case, but if we were to run this, you're just going to get back like question, answer for method 1, answer for method 2, And as well, if you want to change this from false to true, you'll see for each answer response from each model what context it pulled from the database that it was relevant to answer that question. So then we go back to the UI. We now have at this point the vector database that hasn't ever changed. We have a model that we're pretty confident in, having done lots of iteration and lots of testing on actual questions. And again, with this one, because this one has memory, when we ask this question here, we're able to, the model's able to reference back to like these 3 previous ones. So like when we ask here, like, is the candidate verifiably wealthy? And then we follow up with, but did he generate his like wealth from business ventures? The responses are generally nicer because it has that memory aspect to it as well. So getting back to the UI, we wanted to make use of that conversational aspect we had. So I ended up like adding some extra functionality around changing candidates, which we looked at earlier. We wanted to be able to reset the chat memory, i.e. I changed from Kennedy to Vivek. I want to wipe all of my stuff on Kennedy. There's some error handling that always comes in when you're dealing with users and like just anything in code. And then lots of UX improvements so that a user really can't end up and find themselves in a unrecoverable position. So ways to improve. I actually used Google Slides like built-in image generator to get this one, which I think is nice, but in short, there's infinite ways to improve it. You could see with my initial Vivek conversation, it's not perfect, and there's lots more we could do. So thinking of that, I try to come up with a couple of options that would be helpful if you wanted to dig deeper. So one, optimize the underlying data. There was one example here which I figured out came from Dean Phillips talking about someone he met with rather than his own like personal beliefs or feelings. So basically we asked the question of tell me more about the candidate, and it was like Dean Phillips is the first openly gay candidate to run for the president of the United States. According to what I can find in other sources, that is not true. So not that I had to remove that element from the input to the vector store, but I had to break it up into individual lines and tag them separately so that given that question, it would give a better answer. Similarly, there's one about the car he drives being like a Ford F-150, but it was he met with like a Trump supporter who drove that, or he told a story about something like that. So there was extra cleaning I needed to do, not to make someone look better, but just to make the data actually more accurate. So there's lots of methods and probably like PhD papers on strategies here. Get it to a point that you think is like pretty good before you deploy something. And then test out different chunking strategies. We've kind of run through that one. Next up, I guess, is definitely prompt iterations are fundamental to making something that like actually works and actually works well. So that also depends on, if you don't have clean data going into it, you can do whatever prompt you want. It's not going to work well, but you can iterate on it to reduce like hallucination. So by making some like updates to say, like, unless I've given you the context, do not go off and refer to like other context, even if you're certain that it's true. I only wanted to reference what I've provided it with and what I know is accurate. So from that, basically when we ask a little bit, or when we ask the same question of the bot nowadays about tell me something interesting about the candidate without giving it the memory, if it's the first question that's asked, we go from basically a hallucination to something that's like really interesting on the candidate. Like this Dean Phillips guy has like worked with Jay-Z on like Belvedere, was involved in a potential business deal with them, but he's gone off to like really far out like European countries to do some like cool stuff as well. So it gives interesting answers, but it takes testing and testing and testing to get there with the prompts. Improve the initial transcription. Like I mentioned earlier, I was kind of limited in how I tested here. I wanted to run it all on my device. And if I go to embeddings, transcriptions, podcast to embedding, get interviews, audio transcription. There's probably many levels above this small model. I think there's like an extra large model that OpenAI's Distill provides that will probably give you like super nuance in the speech to text. I didn't want to spend like hours burning my laptop to get that sort of 5-10% improvement. Maybe for you it's really important. So improve the initial transcription. Definitely I found that it could be improved on like punctuation, which then ran into the jump from the .txt files to the initial CSVs. Like if that had more better punctuation, we ran some like sentiment analysis, we could have split that into the columns much more easily and more quickly together. But then we jump on to embed more data. So like my Vivek questioning there, that kind of gave back the same result when I asked it a different way. Like his interview wasn't one of the longer ones, but we would just need to, and we do need to like add a lot more information from a wider set of sources to improve coverage and like depth. So if I was to grab all of the relevant interviews with him from media articles or anything like from his website and embed those, we're going to get a greater depth of context. And then I just thought it might be funny to do this for politicians, but like for once you like flip flap on topics. So we'll say fiscal spending. One day they're like spend loads of money. The next day they're saying don't spend money. We could start to use like an LLM, not even a chatbot, to figure out over time, given everything that you know, what has the candidate like changed their opinion on a few times. So you need to feed it in obviously a wide range of sources, but also some like time stamping. So lots more you can do there. Iterate on the LLM. I only tested kind of 2, and they were out of necessity because DaVinci was retired. GPT basically is the one that they recommend in its place. I noticed 0 difference between them, but you could start to use like open source models or other ones provided by they have to pay for. And I think also fine-tuning the model could be important here. Removing, especially for a candidate like Trump or Biden, removing context that the model is aware of that could be biased or maybe inaccurate. You would want to fine-tune the model to be like very precise for your use case as well. Something that I have not gotten into here, so do not take any of this as fine-tuning. And then yeah, further automate the testing. You can even see like when I run my testing here, it is quite like manual, and I have to like manually review it. Like even though it's much nicer to be able to like add a question and like see the result like in your console, you could have an agent or you could have some other like LLM run on top of the inputs and outputs to improve your prompts and give you like real-time feedback on improvements. So yeah, have a go with that and see what you can come up with. Here's kind of the summary of the 6 I'm still thinking about. I want to dive deeper into. I still need to run through like deploying it live so everyone can access it, and then part of that is running it in production. But yeah, overall, thank you for bearing with me for the 59 minutes. If you would like more content like this, please let me know. If you have comments to share, leave it in the description, either on the website or in the comments below as well. And then yeah, please join our community at Build AI First. There's more of this content that's going to come in the coming weeks. And the aim of this one was to dive into chatbots, RAG from a generalistic point of view. It's not going to exactly be useful in in its current form for your business, unless you're one of the candidates. But yeah, join the community, get involved. If you want a deeper dive in one of these sections, please let me know, and I hope to see you in our Slack channel. Thank you.